This is the homework helper for Chapter 8, Section 3, Line and Angle Relationships in the 7th grade workbook. Alright, questions 1 through 4 and 5 through 8 have the same directions. Both say to tell whether the lines appear parallel, perpendicular, or skew. We're going to go ahead and take a look at 5 through 8, but you'll use the same approaches in 1 through 4 that we're about to use in 5 through 8. So, let's make sure we know what we're talking about here. Perpendicular lines are two lines that intersect to form a right angle. Parallel lines are lines that are in the same plane and do not intersect. Skew lines also do not intersect, but they're in different planes. So let's make sure we have a little bit of an understanding of a plane here. Consider the piece of paper that you're seeing in the presentation right now a plane. If I brought another piece of paper into the presentation and hovered it over the one that you have there, that would be like a second plane. All right, these two things, they're not on top of each other like this. This one is actually hovering over this one. So I could draw a line on here and draw a line on the one that's underneath. That would be like two different planes. All right. Whereas if I draw two lines on this sheet of paper, they're either going to have to cross at some point, not necessarily be perpendicular, but they would have to cross unless they're parallel, meaning they have the same slope if we're talking about a line, or they would never intersect. But if they're in different planes, again, they won't intersect because it's like they're in two different dimensions here. All right, so with that explanation out of the way, let's take a look at 5 through 8 here. They're asking me to look at the illustration and tell if the lines are parallel, perpendicular, or skew. So if we're looking at BD and DG, well, as you can see, that's the front side of this rectangle shape that we see in front here. That's the line that goes up and down here on the left side, and the line that goes left to right here on top. Well, obviously, here's your right angle right here where the angle marker for D is. So that means that these guys are perpendicular. Remember, perpendicular means that they meet at a 90-degree angle or a right angle. In number 6, they're asking about AB and BD. Well, as you can see, AB and BD here are the left side of this shape that would kind of look like a square, I guess. Well, here's AB, it's the bottom side of this square, and BD is the line that goes up and down on the right side of the square. Again, picture, maybe you might have to float this around in your head a little bit and turn it around, but that would be kind of a square-looking shape. These sides do look like they're pretty close here. So that means, again, because they're parts of the make up that L-looking shape or a right angle there in that square, these are also going to be perpendicular. In number 7, they're asking about DG and IJ. Well, if you want to talk about that example that I just gave you of the two sheets of paper floating, look where DG is. DG is on the top of this three-dimensional shape here, what works out to be a trapezoid at top here. IJ is down here at the bottom part of the trapezoid. That's kind of like your two different sheets of paper. You've got this piece that's way up here, and you've got this piece underneath it down here. So that's going to be your idea of skew lines. Those two aren't ever going to cross each other because they're just kind of in different worlds. And then with AB and CD, well, again, we're back to this shape that kind of looks like a square over here. Again, if we visualize it, maybe we have to turn it a little bit in our heads. That's the top and the bottom piece of the square there. So those are going to be parallel. Now, as we go ahead and progress to the bottom of the page here, what they're doing at the bottom of the page now here is they're giving you an illustration that includes two parallel lines being cut by a transversal. And what they're doing, asking you to do in each of those is to find the measure of each angle. So if we look at question number 9, they're asking me to find the measure of angle 1 and angle 8. Now there's a few different ways we can traverse around the shape here, and we can really find, angle 6, angle 1 and angle 6. There's a few different ways we can traverse around the shape here, but let's just take the most basic ones here. Let's start with 6 there. In angle 6, if we kind of cover up everything else, we see that what's left there together ends up making a line. Right? If we forget this, there's this little line here called Y. Those two together just make up parts of a line. Well, a line has to be 180 degrees. Any line is 180 degrees. So if I've already got 95 degrees there, I know how many more I need to get up to 180 degrees. In that particular instance, I would need 85 degrees. So angle 6 here is going to equal 85 degrees. Now, as far as getting up to angle 1, you've got some options here. How you go about this is really up to you. What I see here that is probably going to be easiest for us is if we look at 5 and 6 together, or we could look at 5 and the 95. Either way, the result will be the same. If we look at 5 and 6 together, those two also make a line, one that goes left, right across the page there. And because those two together make a line, that means that they too have to make 180 degrees. Well, if I've already got 85 degrees there, that means I need 95 more degrees here to make that line of 180 degrees. You could also look at the 95 we had already marked and the angle marked 5 here and say they're across from each other in that X shape there at the bottom of the screen, which means that those guys happen to be vertical angles. Well, if they're vertical angles, they have to be congruent because that's the property of vertical angles, that they are congruent. All right, well, now that I have 5, take a look at 1. The angle marked 1 is above one of the parallel lines and to the left of the transversal. There's another angle that has that exact same description, angle 5. It's also above a parallel line and to the left of the transversal. Well, when they're like that, that's called corresponding angles. Corresponding angles are angles in the same relative location, and they have the property of congruence. So if we know that angle 5 is 95 degrees, then angle 1 also has to be 95 degrees. So angle 1 is 95 degrees. We've gotten a few others on the way, but we've gotten the two they've asked me for in question 9. Let's try this again in number 10 where they're asking about 4 and 8. Well, if we start off with the angle marked 4 here and the one that they've already given me, 63 degrees there, I see that those two together, if I kind of ignore everything else, make a line there that goes from left to right. Well, if those two make a line there, that means they have to add up to 180 degrees. Well, on this side over here on the left, I already have 63 degrees. So how many more degrees do I need to make this illustration go up to 180 degrees to be a full line? Well, in this particular instance, I need 117 more degrees because 63 and 117 together are going to give me 180, which is a line. So angle 4 is 117 degrees. Now, as far as 8 goes, take a look at where 8 is. 8 is beneath a parallel line and to the right of the transversal. We have another angle that we've already solved for that has that same description, angle 4. Angle 4 is also beneath a parallel line and to the right of the transversal. So that means they have to be congruent. So if angle 4 is 117 degrees, angle 8 also has to be 117 degrees. All right, finally, we'll take a look at question number 11. In 11, they're asking me to find 4 and 6. So let's start with the angle marked 4 here. Now, if we kind of ignore the left side of that illustration for a minute, what we see is that classic X shape. And from that X shape, we know all about the idea of vertical angles. Angles that are across from each other in that X shape have to be congruent. So if we've already got that one that's marked 87 degrees there, we can then find this one over here because they're across from each other in the X shape. So if this is 87 degrees, this one also has to be 87 degrees. So angle 4 is 87 degrees. Now, if we go take a look at angle 6 now, we really don't have any information that translates directly over to 6, so we're going to have to find another way to get there. Let's go with 5 to get there. There's other ways we could do this, but let's go with 5. 5 is beneath the transversal and to the left of one of my parallel lines. There's another angle that has that same description. this angle right here that they started off with us is 87 degrees is also beneath the transversal and to the left of the parallel line. That means they are corresponding in the same relative location. They're both beneath the transversal and to the left of the parallel line. Corresponding angles have the property of congruence, meaning if this one's 87 degrees, this one is also 87 degrees. Now, that doesn't help us with 6 directly, but it does help us indirectly, because what I have left there looking at 5 and 6, well, those two together make a line that goes left to right across the page there. Well, that means they have to add up to 180 degrees. Well, if I have 87 degrees, I just have to figure out how many more degrees I need